Hey everybody, the purpose of this video is to get you guys some solutions to the other distribution quiz that involves a game you're playing with your friend where you flip coins 4 times. If you are flipping and you are betting and you get 4 heads or 4 tails, let's make sure you and I play the following game. If you get 4 heads or 4 tails, I'll give you $1. So I'm going to make this be the distribution of your payouts, right? So if you flip 4 heads or 4 tails, I'm going to give you $1. So 4 heads out of 4, you get positive $1. And 0 heads out of 4, you also get positive $1 because that would be 4 tails. If you flip exactly 3 heads or exactly 3 tails, you give me $1. So either of these 2 cases, you're going to hand me $1. Okay, hand me $1. Boom. There we go right there. And if we flip 2 of each, neither pays the other anything. So that balances out. It's a do-over. Then you have to complete some probabilities to analyze the game. So I tell you off the bat that the chance of 2 heads and 2 tails is 3/8. That's 37.5%. If you're doing, let's use fractions. 3/8, 37.5%. I also tell you that the chance of heads and all tails is the same, and the chance of 3 heads or 3 tails is the same, and this one is 4 times as likely as this one, which means this one is 4 times as likely as that one. Hopefully all that kind of made sense. So essentially you've got 5/8 more to play with. You've got 3/8 here. We know the sum of all the probabilities have to add up to 100%. So there's 5/8 left to play with. Since these 2 and these 2 have to be the same because of the symmetry of this, actually the symmetry of the coin flips, we know that this has to be 5/16 and this has to be 5/16. Hopefully that makes sense. Since this total is 5/16 and this one is 4 times as big as this means 4 of the 16ths have to be here and 1 of the 16ths has to be here. Well, 4/16 is actually one quarter. So we'll just do that, which means this is also 1/4 and this is 1/16. Now, if you didn't like that little talk through, and that's totally fine if you didn't, you can also think of it a different way. You can think of it as, well, here's a couple of different ways to think about it. Number one, now that you have the dist-fill program, you can realize this is a binomial experiment where X can be the number of heads or the number of tails, and you've got 4 trials with 50% probability of heads on any given trial or tails. That's one way you can do it to get these numbers. The other way you can do it is do algebra to get there. And if you want to do it that way, please come by and see me. I'll be more than happy to walk you through the algebra. But here are the numbers we need to use. 1/16, 1/4, 3/8, 1/4, 1/16. So there's part 1 of the quiz. The next thing I ask you to do is figure out your average. Your average, not mine, yours. So on average, what's going to happen with this distribution? Well, your average is just the sum of all the probabilities and their payouts. So you get a 1/16. You get a negative 1/4. This cancels, that doesn't count as anything. Another negative 1/4. I'll put a $sign maybe. And then another positive 1/16. So you can see what's going on here. You're losing money. You're losing money on average because even though you pay me the same amount that I pay you, you get it 4 times as often as I do. So let's sum it all up. We got 2/16 minus 8/16. That's negative 6/16 of $1, which said a different way is this. You're losing about 38 cents a game on average. You're losing about 38 cents a game on average to me, which means out of every 8 games or every 16 games, you're giving me that much money. Well, just think of it over time. Forget the out of 16 games. Over time, you're handing me 38 cents. And I forgot the most important part of that. Excuse me. The most important part of that is the negative sign. It's negative 38 cents per game. So there you go. There's a problem with this game from your point of view is that you're losing money to me. Because if you think about the ways we can win right here, like I said before, you're paying me 4 times as much as I'm paying you. So that's a problem. And the last part is, suppose we want to make the game fair. Now, in the other quiz, and I'm not sure which one of these videos you're watching first, we also talk about the idea of a fair probability distribution is when the average averages to 0. Statistically fair means the average is 0. So I don't want the average to be negative 38 cents per game anymore. No, that's not good. What I want to do is I want to balance that so that you and I essentially can play this game forever. Because we'll keep paying each other back and forth. When you lose, you'll pay me. When I lose, I pay you. But the problem with this one is I'm accruing a debt of 38 cents on every game. I don't want that to happen. I don't want that to happen. I want to make that debt be 0 for both of us. If it's 0 for me, it'll also be 0 for you. So what I need to do is, I think I told you, let me double check. Yeah, adjust your payout to me. Did I say that right? Yes. What should I pay you in this case? So right now I'm paying you $1. So algebraically, there's a couple ways you can think about this. Well, we'll get to the kind of clever way later. If you want to draw it algebraically, which is totally fine, algebra's a great tool. Make these x's. Make those x's, and then solve the exact same equation you did above, but set the average equal to 0. So 0 equals x over 16. Actually, let's do it this way. X over 8, because there are 2 of them, minus 1/2, right? Minus 1/2, because 1/4 and 1/4 together is 1/2. Solving that for x, you end up with, well, that's nice. X exactly equals $4. That's how much you should pay me every time I win, if I want the average to balance. And again, make peace with y, right? Make peace with y. If you pay me $4 and I only pay you 1, you win 4 times as much as me. So since you win 4 times as much as I do, make it simple, every 5 games, you win 4, I win 1. You win 4, I pay you 4, I win my 1, you pay me my 1 back. So it ends up being a nice balance at the end of the day because of this tied right into this. And hopefully that makes sense. I hope it does. Yeah. So I hope that got you some solutions to the quiz.